right, we're actually 6 minutes into class here, and we're still missing 7 people. And a lot of the ones that are here don't even have their cameras on. So let's put up our buzz screen. Okay, looking at our grade screen, let's see where we stand. All right, so we've had the parabolas, ellipses, hyperbolas, and the collage, which could be a combination of all of those things, including circles. Circles are allowed, even though we didn't really study circles. But parabolas, ellipses, hyperbolas, circles could all be on your conics collage. So hopefully you've got that turned in. I got mine turned in this morning, actually. It was due yesterday. Looks like we're to the end of Module 6. We have the practice exam and the actual exam. So we're going to wrap that up this week. Next week, we're going to start matrices and then spring break. So we got one more week after this, and then we'll hit spring break. But let's go look at the practice exam. See how long it is. Now, the practice exam, remember, you can take it as many times as you want to because it's a practice grade, and it's just for you to figure out, do I know enough to take the test, or do I need to go back and study parts of this? Find the vertex, focus, directrix, and focal width of this parabola. Negative 1/40th x squared equals y. Well, look at the x and y. The vertex is going to be 0, 0 because there's no hk. And then we'll figure out the rest of that. Let's say standard form of the equation. Find the standard form of this equation. Here's one of those that we've got a building that has an entry, the shape of a parabolic arch. Which equation matches this arch? Find the center vertices foci of this ellipse that has this equation. Same thing, ellipse with this equation. See different equations there. Graph the ellipse that has this equation. So which one of these 4 graphs is that going to be? So there is no HK. So it has to be the only one that has a center on the origin. If we look at this, the larger number is on the y. Y squared over 49 is larger than x squared over 36. So the A is 6 and the B is 7 because this is A squared and B squared. So we're looking for one that is 7 tall and 6 wide. So it looks like this one right here. Center is the origin, goes up to 7, goes over to 6. Both directions. This one's not on the origin, even though it looks to be tall enough. This one is on the origin, but this is 7 wide and 6 tall. See, but the larger number's under the y should be 7 tall. So that's just turned sideways, and this one's not on the origin. So it has to be this one right here because the numbers line up. If we graph that in Desmos just to double check ourselves, which I always encourage to do. You can do that even on a test if you want to go to Desmos. X squared over 36. X squared divided by, oops, not the squared, divided by the whole thing, divided by 36. And this was plus y squared over 49 equals 1. Oh, not under the 49. You got to get it. It keeps wanting to put everything under the parentheses. Okay, there it is. Look, it should go up to the 7. It should go up to the 6. So it's taller than it is wide. The center is on the origin. So this would be exactly correct right there. 7 high, 6 wide, center on the origin. Find the equation in standard form for the ellipse as a vertical major axis of length 10 and a minor axis of length 8. Okay, we'll look at that. Find the vertices and foci of this hyperbola. Here's the equation. Graph the hyperbola that has this equation. Okay, well, look at this has an x and an h and a k. I'm sorry. X minus h. So the center of this hyperbola is at 1, -3, because it's y minus k. It's plus 3. Must be y minus -3. So we want one that has a center. Now this has a center right on the x-axis because there's the vertex, there's the vertex. So this one's ruled out already just by the center. This one has a center, it looks like, at 1, -3. So that's a possibility. This is right on the y-axis. That's ruled out. And this has a center at -1, +3. Oh, so just by looking at the center, it has to be that one. Not even looking at the a and the b squared and all of that good stuff. It's got to be this. Now, I'm going to prove this to myself by graphing it. X minus 1 squared. Oh, let's see. X minus 1 squared. And it's y plus 3 squared. So I'm just modifying the one I already had there. And it's over 49 and 9, and it subtracts. 49, 9, and it subtracts instead of adds. So there it is. The center is at the 1, 3. Oh, -1, 3, sorry. Well, -3. I got the negative in the wrong place. There is the center between the two vertices, and that is the one that we chose. It's right down here. So it is a horizontal hyperbola. So that wasn't too hard. Find the equation in standard form for hyperbola has these vertices and foci. And oh, look, there's only 12 problems on the practice test. That's a pretty small practice test. Usually we got 25, 30 questions on a lot of these. So let's work through these and just make sure we understand how to do this so we can take the test and do well on that. So the first one, write this down. Okay, so we need our hyperbola notes. Our parabola notes. So here it is, where we find the vertex, axis, focus, directrix. Here's our equations. So it depends on this is vertical or horizontal. The one we have is a -1/40 x squared. So it looks like that would be x squared would be a vertical, right? So if it's 0, 0 as the vertex, then x squared equals 4p over y, 4py. Now this one, it's put the x squared, the coefficients over with the x squared. So we need to move it over with the y side so we can start pulling all these numbers together. So since this is -1/40 x, we just want x squared. See, we just want x squared on that side. So the vertex is at 0, 0 because there's not an h and a k in our equation. And if I have -1/40, if I multiply that by -40, which means I need to do it to both sides, -40 times -1/40 is just a +1. So that's just 1x squared. And over here, I've got -40y. 4p is -40 in our case, right? So 4p -40. So p equals -10. And what is p? P is the distance from the vertex to the focal point or the vertex to the directrix. So ours is -10. So if this is a negative, so this is a downward facing parabola. And our vertex is at 0, 0. So the focal point is at 0, -10. Right? So that's the focal point. And the focal width, let's see, 4p is the width at the focal point. So that's the focal width. So the focal width is -40. Well, it's +40 because the width can't be a negative. It's actually the absolute value of the number. So I guess I should change my notes to say this is the absolute value. So it's a width of 40. The vertex 0, 0. The focus. The directrix would be the line that's above here at 0, 10. That would be the directrix because remember it's the same distance from the vertex to the focal point down here at 0, -10 as it is to the directrix. So let's see if we can find the multiple choice when it has these 4 points. Yeah, they all have the vertex at 0. The focus point, we said, is at 0, -10. There's 2 of them that have that choice. The directrix will be above that at 10, but the focal width, it has to be this one at 40, not 160. It's 4p, but p is -10, not -40. They're trying to fool us with having that -40 on there. So this should be the answer for the vertex at this. And let's see. I'm going to go ahead and graph this again because I just want to double check my work. So I'm going to graph it exactly like it's written right there. -1/40 x squared equals y. At the focal point of 0, -10, how wide is it? 10, 20. It is 40 wide. See, it goes to 20 over here and -20 over here. So the focal width is 40. So that pretty much confirms I've got the right answer right there. Only one of them had a focal width of 40 of all the 4 choices even. So. All right, find the standard form of the equation of the parabola that has a focus here and a directrix y equals 2. So let's see. Oh yeah, the directrix was y equals 10 over here. I wrote that wrong. Let's see. Okay, so this one has a focus point 0, -2, and directrix y equals 2. And they want the standard form of the equation. So yeah, this was y equals 10. Because the directrix is a line. It wasn't 0, 10. It was y equals 10. So if the directrix is y equals 2 and the focus is 0, -2, so this is also a downward facing parabola because this is the directrix line at y equals 2 and this is 0, -2. So our vertex is going to be 0, 0 because it's 2 away from each of those is 0, 0. So we're looking for an equation that has x. Oh, let's see, not y. Erase that. New eraser. X squared equals negative 4py. Now, our equation normally x squared equals 4py, but since it's downward facing, I know it has to be a negative because ours goes down because the focus point is below the directrix. So let's figure out these distances. We know p is the distance from the vertex to the focal point. Well, the vertex is at 0, 0. So it's p is 2 because that's how far it is from the vertex to the focal point or the vertex to the directrix line. So x squared equals -4 times 2. That should be the equation we're looking for. X squared equals -8y. And again, I'm going to test that real quick. X squared equals -8y. Okay, and that is downward facing. If we put the focal point on there, -2, it should be 8 wide at that point. It is. It goes from 4 and -4, so that is 8 wide at the focal point. So that looks right. So let's see, x squared minus they put it in y equals. They made it y equals. So if I convert this to a y equals, I just have to divide both sides by -8. So there'd be y on one side because that's just cancels each other, and this would be x squared over -8, or as they put it, -1/8 x squared. That's the same thing as x squared over -8, but putting it out as a coefficient. -1/8 x squared. So it'd be the bottom one there. All right, another parabola question. Focus at -8, 0. Focus -8, 0. Directrix x equals 8. Okay, this one looks different. Take a look at it. What's it going to look like? The directrix is x equals 8, so it's an up and down. The focus point is at -8, 0. So it's over here. So this is a left-facing parabola. So this one's going to look like this. And where is the vertex? Well, halfway between -8 and +8, the vertex has to be at 0, 0. So this is going to be a 0, 0 vertex, which simplifies things. Since directrix is 8 away from that, and that's -8 away from that, P equals 8, because that's the difference between the vertex, the distance from either one of those. Since it's a left facing, let's see, we need our notes for that. So this is a horizontal. Let's see, when it is no h, no k, we're looking at just y squared equals 4px when x and k are 0, right? So we're looking at the standard y squared equals 4px. But in this case, since it faces left, it's going to be a negative. This is when it's negative. This one is positive, the coefficient. So we're going to have negative 4px. So y squared equals, p is 8, so -32x. Or if they put it the other way, we divide by -32, it could be -132 y squared equals x. So we'll look for either one of those versions. Dividing by -32 gives us this, or so we'll see which one of those is the multiple choice. Oh, we can go ahead and graph that while we're at it too. Y squared equals -32x. Yeah, that looks right. At -8, the width should be 4 times that, should be 32. And it looks like it is, because this, if you go up, that goes all the way to the point 16. So that's 16 higher. So this will be 16 lower. So this should be a focal width of 32. So that looks right. They gave us the second one where you divided by -32. X equals. They got y equals just to throw you off there. But we're looking for the x equals -1/32 y squared, which was this one where they divided by the -32. All right, here's one of those ones that has a building has an entry the shape of a parabolic arch. I'll draw this just so we get a good picture of what we're looking at. It's 84 feet and 42 feet, which means it's not drawn to scale, right? Because the 84 is twice as big as 42. But let's play with it. So ignoring that, this should be a lot farther down because 84 is the height of this parabolic arch. So this is a up and down. So this is vertical. And we know it's a negative because it points down, right? Because this is positive, that's negative. So with the vertex of 0, 0, we're looking at x squared equals -4py. So x squared equal -4py. So to find what the equation is going to be, let's take this point right here. What is that point? This point, we know it's at -84 because it's 84 is the distance below the x-axis. So we know the y-coordinate is -84. The x-coordinate, this is 42, but here's where the origin is, 0, 0. So this is 0. So this is only half. It's 21. So the point 21, negative 84, which is right there, or negative 21, positive 84 right there. We know this point is on this equation. It's on this line. Now our negative may mess up. We just know when we're done, there has to be a negative out here because this is a downward facing parabola. We can substitute these values into our equation. So the x is 21. So 21 squared equals negative 4p, and the y is negative 84. Solve for p. We can find out what the p is right here. So let's get our calculator out and see if we can't do a little math. What is 21 squared? 21 squared. 441. 441 equals negative 4 times negative 84 times, so 336 y. So we need to divide both sides. So this is going to be a fraction, but does it turn into a nice fraction? If we divide 441 by 336, 1.3125. No, that's not a nice fraction. So we need to simplify this in whatever way that we can. Let's see, what's going to go into 441? That's the big question. 441, let's divide it by 11. Does it divide by 11? No, it does not. It's an odd number, so it's going to divide by some kind of odd number. Let's see, will it divide by 7? 63. Will the bottom divide by 7? 336 divided by 7. 48. So this is 63 48. Oh, this is P, not Y, because we knew what Y was. We substituted Y in there. So that equals P, 63 48. This is 9 times 7, or 3 times 21. Oh, this is 3 times 16. So we can bring more out of this, right? So if we divide the top and bottom by 3, both of them. So this is 21 over 16. That should work. But first we divided by 7, and we got down to this. And then we found out that, oh, we can divide by another 3. So both of these would have divided by 21, it looks like. Let's try it. So 336 divided by 21 is 16. And 441 divided by 21 is 21. Oh, I messed it up. Divided by 21 is 21. So 21/16. So that's about as simple as it gets, because this is 2s or 4s go into that, or 8. 3 and 7 goes into that. So that's as simple as it gets. So our equation is going to be x squared equals, get this calculator out of the way now. P is this, and we need it to be a negative. Oh, that's just what P is. We need 4 times that. So this would be 84/16. When you multiply it by 4, which is 4 over 1, negative 84/16, which now we know that will simplify as well, because that is divisible by 4. Does 16 to go into 84? I believe it very well might. 84 divided by 16. Nope, 5 1/4. Doesn't go in there. All right, well, let's divide 4 into both of them. So 84 divided by 4 is, so negative x squared equals negative 21/4 y. Or as they've been doing to us on the other one, we would have to divide both sides by 21/4. When you divide by a fraction, you have to flip it. So this would actually end up y equals negative 4/21. Which one's squared? The x is squared. X squared. Let's see if that looks right. Negative 4/21. When you divide by a fraction, you turn it upside down and multiply. Let's see, was this the, no, we're doing a different one. It's not this one. The vertex is at 0, 0. Vertex is 0, 0. And we know that it has to go through the point 21, comma, negative 84. It has to go through that point if we've done it right. It's got the vertex of 0, 0, and has to go through that point. Here's the equation that we think we're using. Equals negative 4 21st x squared. Hey, look at there. It goes through that point. I think we've got it right. Negative 4 21st x squared. Has the vertex of 0, 0, and it does pass through that point. So this is what that parabolic arch would look like. And they did the decimal. Look at them. And they did the x squared version equals negative x squared equals negative 5.3y. That'd be this. X squared equals negative 5.25, but they rounded it to 5.3y. So it should be that one right there. Ellipse. Find the center, vertices, and foci of this ellipse. All right, so we're going to need to switch to our ellipse. So that was the parabola. See, that's hyperbolas. Ellipse. Ellipse deals with A and B. If it's horizontal, the A is under the X. If it's vertical, the A is under the Y. The A is always larger than B with ellipses. So the bigger numbers under the Y, it's taller. If the bigger numbers under the X, it's wider. Okay. And we knew C squared equals A squared minus B squared. The A is the distance from the vertex to the center on the major axis, which is the longer axis, whichever way it goes. B is the shorter axis. So let's see what they gave us. They gave us two equations. No, they gave us one equation. So I'm going to turn this over. Oh, I already got work on the back of that page. All right, let's get a blank page. So we can write this down. So since the larger numbers on the Y, that tells us right off that this is going to be a vertical ellipse. So what is A and B? Let's find that first. Since this is B squared equals 81. B equals 9. And since we're talking about distances, because B is going to be the distance, we just use the positive one. A squared equals 225. So the square root of both sides, A equals 15, because 15 times 15 is 225. So now we know A and B, and they want us to find the center, the vertices, and the foci. Okay, well, the center, since we just have no H and K, center is HK. That's where the center is. Right, so center, don't even have that in our notes, do we? Center, HK. Well, we don't have an H or a K, so our center is at 0, 0. The two focal points is a distance of C. Well, we'll have to calculate C, but we can get the two vertices. They're a distance of A away from that. So vertices would be 0 plus 15. So this would be, well, one's going to be at negative 15. Oh, I said this was up and down, though, didn't I? Well, it's up and down. Got to pay attention. Since it's up and down, the X doesn't change. Be 0, comma, negative 15 and 0, comma, 15. Because this is up and down. So A is going this way. This is A from the center. A is up and down. And the focal point is going to be from the center, wherever the focal point is, a distance of C. So the foci we got to calculate what C is. Now, if we go back to our notes, C squared equals A squared minus B squared. Okay. So C squared equals A squared, which is 225, because that was on our equation, minus B squared, which is 81. So C squared, we need 225 minus 81, which is 144. So C equals 12, square root of 144. So the foci are at 0, -12, and 0, 12. All right, let's see if we can find a multiple choice that has those points. 0, -15, and 15, foci, -12, and 12, 0. There, okay, there, that should be the correct answer. We can test real quick to see if we at least have the vertices right. This is x squared divided by 81 plus, I guess I need to zoom back up here. There we go. Oh, don't put the plus underneath there. This one's driving me crazy. The plus is over here. Y squared divided by 225, and it all equals 1. So here it is. And the vertices are at 0, 15, and at 0, -15. And we figured out the focal points are in here at 0, 12, 0, -12. But since the vertices are right, that's great confidence that we've got the rest of it right. So it would have to be one of these two middle ones, because this has the x as being the 15s. And so the focal point would either be at 12 and 9. And we calculated the a squared minus b squared. It is 12. So we're confident with that. Okay, again, center, vertices, foci, and ellipse. But we've got to change the equation first off. So let's see what equation they've given us. 2x squared plus 8y squared equals 16. Okay, this is actually a pretty simple one. Since we need them always to equal 1, whether it's a horizontal or a vertical, it should equal 1, and ours equals 16, we just have to divide by 16. So this simplifies to, let's see, 2 into 16, that'll be 1 and 8, right? So this would be x squared over 8, because 2 to 16. 8 and 16, this would be 1 and this would be 2, right? There's 8, divide both by 8. So y squared over 2 equals 1. So there, this is a squared. A squared equals 8. So a equals the square root of 8, which is 2 square roots of 2, if you simplify it. B squared equals 2. So b equals the square root of 2. A is always larger than b, so this is a horizontal ellipse. And again, they want us to find the center, vertices, and foci. And look, they're using 2 square roots of 2 and 2 square roots of 15, square roots of 6. So they're leaving it in square root form. The center is at 0, 0, because we don't have any h or k. So let's figure out which one of these works. Since we know a is 2 square roots of 2, since they simplify it that way, we know that's the distance between the center, which is at 0, 0, and the vertex. So the two vertices would be subtract 2 square roots of 2. So this would be -2 square roots of 2, comma 0, and add 2 square roots of 2, 0. That would be the two vertices. One of them is -2 square roots of 2 to the left, and then we add 2 square roots of 2 to go right, and that's the 2 points. Now we need to find what c squared is, right? And because c is the distance between the foci and the center. And we know c squared is a squared minus b squared. So c squared, a squared is 8. B squared is 2. C squared equals 8 minus 2. So C squared equals 6. C equals the square root of 6. So that means the focal points will be at negative square root of 6, 0, and positive square root of 6, 0. Let's see. The vertices are at negative, this one. Oh, that's got to be it, because there's not another one that has negative 2 square roots of 2, 0, and 2 square roots of 2, 0. These have vertices at negative 8 and 8, and 0, negative 8, and that is the negative square root of 6 and 0. So that's good. All right, we already did the graph. Here's another ellipse. Oh, this one's a little different. I like this. This says find the equation for an ellipse with a vertical major axis of length 10. So we need to draw this. If we draw that, this is 10, right? And this here is 8. So drawing it from the center to that is the larger leg. A equals 5, because it's half the distance, right? This would be B, and it would equal 4, because 8 is the distance all the way across. So from the center, it would be 4. So the equation would be the A is under the Y, so B is under the, because it's taller than it is wide. So that means the Y has the larger one. So this is X squared over 16 minus Y squared over 25 equals 1, because it's B squared and A squared. B squared, A squared. X squared over 16. Let's test ourselves just to make sure that's right. X squared over 16, Y squared over 25. Look, it goes 5, 5, 4, 4. So that's a length of 10, a length of 8. That should be perfect. There it is, X squared over 16, Y squared over 25. Okay, so we had 4 questions about parabolas, 4 questions about ellipses, and we've got 4 questions about hyperbolas. 1 of which we've already done, because it was just the graph. So let's see, we need our hyperbolas notes then for this last ones. It's the x minus h squared over a squared minus y squared. Remember on this one, to go vertical, A and B already stays where they're at. This time the x and y trade places if it's a vertical as opposed to a horizontal axis. And we're talking about the axis being, what are we looking at? We're looking at, here, let me highlight this. Horizontal transaxis or a vertical transaxis, which is the line that connects the 2 vertices. All right, AB, we got the distance from the focal point to the vertex out here. A is the center to the vertex. C is the center to the focal point, which is outside there. And we have the Pythagorean theorem works for us this time. So, all right, so we got those notes. And what do we need? We have an equation. So let's write down the equation real quick. Okay, so the first thing you need to know then, if we're gonna figure out the distance from the center to the vertex and the center to the focal point, is we need to know the center. And we have x plus 5 and y plus 1. So the center, which would be hk, if it's x minus h, h must be negative 5. Because x minus negative 5 would be x plus 5. X minus k, k must be negative 1. So we're starting off of this center point. And we have x and y instead of y and x. So that means this is a hyperbola that looks like that. It's got focal points going to be on the x-axis across, well, not the x-axis, but going left and forth with the x's, because we're not on the x-axis, we're at the center point. But we're going to add to the x's and subtract from the x's to get the points that we need. So ours looks like this with the transverse axis right there. Our center is right there at negative 5, 1. We need to find what the vertices are and the focal points, which are out here. So the vertices are a distance of A away from the center. And A, we have A squared under the X. So if A squared equals 36, A equals 6. So the vertices would be 6 away from the center, which is at negative 5, negative 1. So if we went 6 to the left, that'd be at negative 11, negative 1. And if we go 6 to the right, 1, negative 1. All right, because we start at negative 5, we go 6, that'll take us to positive 1. Okay, let's see if that eliminates anything over here. Vertices, negative 1, 1, negative 1, 11. Do I have those backwards? 1, negative 1, negative 11. Oh, there's the one I have right there. We may not even have to find the foci, but we'll do it just to make sure we're right, because this is the only one that matches what we've done so far. So either we've done something wrong or we already know the answer. So finding C, because the foci are C away. This is a distance of C from here to here. Pythagorean theorem, A squared plus B squared equals C squared. B squared equals 64, so B equals 8. So A squared plus B squared equals C squared. 36 plus 64 is 100. C equals 10. So we're a distance of 10 away. So the foci from negative 5, negative 1, be at negative 15, negative 1, and going 10 the other direction to the right puts us at 5, negative 1. So negative 15, 1, 5, 1. Yep, that's what that has. So I think we're in good shape. Let's graph it just to double check ourselves again. This is x plus 5 squared, and it is over 36. And, oh, this is a minus. That's why it's making a circle right now. It's not hyperbola. And this is y what? Y plus 1. And it is over 64. Ooh, not 645, 64. All right. The center, we said, is going to be at negative 5, negative 1. That looks about right. What is this vertex? Negative 11, negative 1. We have that as the vertex, and the other vertex will be over here at 1, negative 1. All right, I feel good about that. All right, just 2 problems left because we've already done this graphing one. So we need to find the equation in standard form, the hyperbola that has these vertices and this foci. All right. What is exactly in the middle between there? That'd be where the center of our hyperbola is. So plus 2 minus 2. So the center is at 0, 0. We have an origin. That's nice. That simplifies our equation where we don't have to have the h in the case. This is moving left and right. Oh, I'm sorry, up and down. It's moving up and down because 0, 0. If we kind of look at that as a graph, 0, 0 be there. 0, 2, and 0, negative 2 would be above and below. So our transverse axis is going up and down. Transverse axis is going up and down. So the y is going to be over the a. So what is a? A is the distance between the vertex and the center. So a equals 2. The foci, remember, that's C away from the center. So C equals 11. And we need B. So since A squared plus B squared equals c squared. A is 2, so 4 plus b squared equals 11 squared is 121. Subtract 4. B squared equals 117. So b is the square root of 117, which I believe is a prime number. We can't simplify 117. We can double check a few things real quick. Let's see if we put 117 divided by 7. Nope, that doesn't work. 117 divided by 3. Oh, but by 3. Oh, there it is. It's not prime. Okay, so, but 3 doesn't help us at all either. But 39 does work. So wait a minute. That means that's 3 times 13. So it's 117 divided by, I'm sorry, 117 divided by 9 is 13. So this is the same as 3 square roots of 13. Because 9 times 13 is 117. Square root of 9 is 3, so it can come outside. So that is the distance that B is. So if we do our equation, we've got x squared, y squared. Oh, wait a minute. We said this was up and down, so the y has to be on the left side. Well, let me swap that. Pay attention. This is y squared over here. This is x squared over here. And over a, we said a squared, since a is 2, is 4. And what is b squared? Well, 3 square roots of 13 squared. B squared is 117. We calculated what b squared was right here. So that should be our equation. Oh, but we had to find the focal points. Pardon me. We found the equation. No, we want to find the equation, right? They gave us the focal point. Okay, let's see. This should work. Make sure we're looking for the right thing here. I got off on that. We have y squared over 4, which is either the first or last, and 117. So it should be that first one. Y squared minus divided by 4 minus x squared of 117. Okay, the last one. Oh, good. This one gave us the vertices of 0 plus or minus 8 and gave us the asymptotes. Y equals plus or minus 1/2 x. I love it. Okay, so the vertices, that tells us that our center is at 0, 0. And since this is going up and down again, just like this one, we know it's a y squared minus an x squared equals 1. We just got to know what a and b is. Well, if you remember right on the asymptotes, it uses a and b, k plus a or b. Well, what's our k? Our k is 0. So ours is just going to be either b over a or a over b. So it's given us a and b. We just got to figure out which is which. We said ours is vertical. Our transverse axis goes up and down. So that means the vertical one, where's my notes? Vertical is a over b. A equals 1, b equals 2. A over b. So y squared over 1 minus x squared over 2. So this really just simplifies to y squared minus x squared divided by 2 equals 1. Because y squared over 1 is just y squared. Let's see if that's one of our choices. It is not one of our choices. Okay, did something wrong. Something about the vertices, right? Oh yeah. So our a, that's the big clue. 1/2, but we know the distance between the center and the vertices is 8. We know a is 8, but 1, 2 is what we end up with a over b. So if 1/2 equals 8 over something, it simplifies to 1/2. So B must be twice as large. B must be 16. Because 8 over 16 would simplify to 1/2, and that's what we use in this equation here. So that's why we need to know the vertices. We need to know what is A. A is calculated the difference to the center. So this is 8 squared, and this is 16 squared. So this is over 64, and 16 squared is what, 190? No, something bigger than that. Bigger than that. 256? 16 squared, 256. Oh, yeah, 256. 16 squared is 256. So that's the equation we're looking for. Y squared over 64 minus x squared over 256. Let's go back. There it is at the bottom. Y squared over 64 minus x squared over 256 equals 1. And that's all of the problems. Have we done everything? Let's see if we're correct. We did everything right. We should have 100%. And we do. 100% right up there on the right. Okay, so we've got all of these correct. We've got 100%. Let's go look at the actual test for you guys. Oh, look, here's a video of me taking the practice test again. So if you need another help later, you go back, oh my gosh, what did Mr. Brock do on the fourth problem? Well, here's the video right here, and you can just fast forward. You can make it big if you want to. Let's just fast forward to the fourth problem. See what Mr. Brock did on the fourth problem. 43-minute long video. You can just fast forward to whatever you need. And I did it on paper right there, so I had all the problems printed out. So that is right here in Buzz. Okay, Mr. Brock takes the Module 6 practice test. Let's look at the exam. Find the vertex, focus, directrix, focal width of this parabola. Find the equation of the parabola. Equation of the parabola. Here's one of these parabolic surfaces. It's a parabola, and it gives you the depth. So find how far is the focus from the vertex. So how far is the focus? If this is 20 meters wide, this is 1 meter deep. All right, that's a little different. Ellipse, find the center of vertices focus of the ellipse. Another one with the ellipse, the equation's a little different. Hint, divide by 21. Here's one, graph this. Which one of these graphs matches that? Find an equation of standard form for the ellipse that has a major axis, 18 minor axis, and it's a vertical. Find the vertices and foci of this hyperbola. Graph this hyperbola. This is almost exactly like the practice test. It just has one extra problem. It's got a railroad tunnel. And the height of the tunnel at the center is 35 feet. And the vertical clearance must be 21 feet at a point 8 feet from center. Like, what does that mean? Okay, this doesn't work. It's supposed to allow me to write on the screen. Anyway, that means there's a point right up here that has to be vertical 21. It has to be 21 feet high, and it's 8 feet. So the point 821 is a point on that parabola. The point 821 is a point on that parabola. So you would solve it the same way like we did with the, we showed a picture frame or a picture or a doorway, an archway. You know a point that's on the parabola, so you use that point to find the equation, to solve for P or whatever you're looking for. So use that. This is a semi-ellipse, which means this is an ellipse equation. This is just half of it. You can only see half. The bottom half is assumed. So you're using your ellipse equation, and it's longer than it is tall. And it's 35 feet tall. So you know that point right there is 0.35. But you know 21.8 has to be a point on that. So think about that one. Don't jump right into it without giving some thought what you're looking for. This has to be 35. So that means if that's 35, the ellipse is the total of 70. So that means really B is 35, right? Because that is the minor axis is 35 from the center. So that gives you your B right away. And you know an XY coordinate that's on the ellipse. It's at 821 on this one. You may have a different problem. So if you got the B and you got the X and the Y, and you can say it's that the center's at the origin, you're just solving for A then in that equation. Substitute what you know for X, substitute what you know for Y, substitute what you know for B, and you're just solving for A. And then you could be able to get the entire equation. Find an equation for the ellipse. All right, that's a fun one. That's a fun one. 13 questions. 13 questions on the exam. Take your time with that, and make sure you got it. If you need, I would recommend going through the practice test. Make sure you know how to do those. I know I went through them all in class. I also have that practice test video there that you can look at. But make sure you feel good going in, because this is a test grade. It counts more than these little smaller assignments we did. So this can move your grade more than those did. And if you haven't done some of the parabola, hyperbola, ellipse assignments, do those before you do the test. Those are good practice to make sure you do well in the test. So get those done if you're missing any of those as well. So, all right, if you got any questions, hang around. Otherwise, I'll let you guys go get started on this practice test. You got plenty of time before your next class. So have a great week. It is a B day, so I'll be here Wednesday if anyone needs it.